Okay, I'd like to show a couple more examples of using method number 1, exploring all the possibilities to try to factor these two trinomials. So let me start with the first one here. By method number 1, I'm going to look at the factors of the constant term and the leading coefficient. So the factors of the constant term are 1 and -5, -1 and +5. The factors of 2 are simply 1 and 2. I don't need to look at -1 and -2 because I've already explored the negative options over here. So I'm going to float my fingers real quick and look for the sum of the products that adds to 9. So let's check that out. 1 times 1 plus 2 times -5. And what I do in my mind is I just start multiplying these things so that I can add them right away. So when I look at that, I say 1 minus 10. 1 minus 10. No, that gives me -9. That's not going to work. What if I do it the other way around? 2 minus 5. Nope. So I'm going to move on to the next two numbers here. -1 plus 10. That's it. So I need these two sets of numbers in this order. 1 times -1 plus 2 times 5, and I should double check that just to make sure I've been accurate. This gives me -1 plus 10, which is indeed 9, so I found what I'm looking for. That means that right away I can plug this into my solution. 1x goes here, 2x here, and remember the numbers that they were multiplied by show up in the other binomial. So -1 there, plus 5 because it's positive right there, and these are the factors of 2x squared plus 9x minus 5. Let me move on to looking at this larger polynomial in some respects. The numbers are certainly bigger, and notice that I've got an x cubed, an x squared, and an x. What I've been showing are methods for factoring ax squared plus bx plus c. That's important, and in fact, if I don't do something ahead of time, I'm not going to be able to factor this using other methods, or I shouldn't be able to. So the thing I need to do ahead of time is factor out anything that is a common factor of every one of those terms. Notice that 10 is a common factor of all those numbers. Notice also that x, at least one factor of x, shows up everywhere. So I'm going to take out 10x, and what I have left is 6x squared plus 11x minus 35. Now this looks like a trinomial I can work with, ax squared plus bx plus c. The thing that I took out right here, the common factor, we can just call it a common factor. If we take out the largest common factor possible, that has a name, it's called the greatest common factor. Common factor. And we can call that the GCF. If you're wondering what kind of method can I use when I take out that greatest common factor, how do I know what remains? Well, you can always divide the original polynomial by that greatest common factor that you're taking out, putting off to the side, and that will give you the terms on the inside. So now I'm going to focus on this trinomial on the inside of the brackets here, looking at the factors of -35, which are 1 and -35, 5 and -7, 7 and -5, and the other way around. -1 times +35, -5 times +7, -7 times +5. That's quite a list, and this is going to produce quite a number of options, especially if there are several options for the leading coefficient. Thankfully, there are only a couple, 1 and 6, 2 and 3. I don't need to explore the negative options because I've already done it over here. Now I'm going to use the two index fingers to try to figure out what sum of products is going to give me 11. So let's try this out. 1 minus 6 times 35, I don't think so. How about 6 minus 35? Not even close. How about 5 minus 42? No. 30 minus 7? No. How about 7 minus 30? Nope. 42 minus 5? No. Negative 1 plus 6 times 35, that's way out of range. How about negative 6 plus 35? No. How about negative 5 plus 42? No. Negative 30 plus 7? No. Negative 7 plus 30? Nope. Negative 42 plus 5? No. So I have explored all the options that come from the first set of numbers here and all the numbers over there. I'm going to move on to 2 and 3. Now, of course, if you have a feeling, go with that feeling and move ahead as fast as you can. So let's just try this. 2 minus 3 times 35, no. 3 minus 2 times 35, no. How about 10 minus 21? 10 minus 21 is negative 11, so that's pretty close. Maybe instead of 5 and negative 7, I should go with negative 5 and positive 7 in the same way. Let's see, that would give me negative 10 plus 21, and there it is. So I'm going to box this. These are the numbers we're using. These are the numbers we're using in this order. 2 times negative 5 plus 3 times 7, and always double check it. This gives me negative 10 plus 21. 21 minus 10 is indeed 11, the middle term I'm looking for. So I'm going to start producing factors. This gives me a 2x. The 3 I can drop down for 3x. The negative 5, remember, has to go in the other binomial. Here's my minus 5. The 7 has to go over here as plus 7 because it's positive. And in the end, don't forget about your greatest common factor, 10x. That's got to remain and go out front. So it turns out that this trinomial actually has 3 different factors. 10x is one of the factors, the binomial factor 2x plus 7, and the binomial factor 3x minus 5. You can always remultiply these things, remultiply the binomial, see if you get the trinomial, multiply back in that greatest common factor, and you should end up with the original polynomial. So let me move on from method number 1 to show you a couple other methods that you might like.